Okay, we're talking about the formulas for linear functions. We're going to interpret the effects of different rates of change, or slopes, and the initial values, RB, on the graph of a linear function. And then we're going to be finding formulas representing linear functions. So again, here's our formula, y equals b plus mx. The y-intercept is written first. This is in keeping with the idea of a linear function as a model starting from some initial value and having a constant rate of change. So that's why I want to have the b first. This is your initial value and your constant rate of change. So if we were to look at these two formulas I have here, it says explain the significance of the y-intercepts and the slopes. Well, the y-intercept of this linear function is 2. The y-intercept of this linear function is a 4. And then the slopes of this one is 0.3 for number 1. And the slope for this other one is 0.25. So if we were to look at these initially, so I know right now that this one starts at 2, this one starts at 4. So I know this one starts higher, this one right here. But then the slopes, this is 0.3 and this one's here is 0.25. So even though this starts higher, the slope is less, so it's not going to be as steep. So let's do a little sketch to see what they would look like. And then you can see what I'm talking about. So let's just do a little sketch, and I'm going to exaggerate a little bit. So here's my formula. So this one's going to start at 2 and have a slope of 0.3, which this is steeper than 0.3, but I want to get the point across. This one's going to start at 4, and it's going to have a slope of 0.25, which isn't quite as steep. It's less steep. So eventually they're going to cross. They're going to cross somewhere. I don't know where, but they will cross. So down here it says, will the lines intersect? They say yes, they will, eventually. And the reason why they will is because their slopes are different. If they would be the same, then it would be parallel, and then they'd never cross. But because your slopes are different, they're going to eventually cross. All right, I have a grapefruit question here for you. See, I found this cute picture of a grapefruit. It says it's thrown in the air. Its velocity v is a linear function of t, the time since it was thrown. A positive velocity indicates that the grapefruit is rising, and a negative velocity means it's falling. So that would be a positive velocity. This is a negative velocity. So we're going to check out the data here on this graph, and we're going to find a formula for v in terms of t. So if they give you these points like that, do the carets and say, okay, this is going up 1, up 1. They said it's linear, so I know it is, but it still doesn't hurt to check with your carets. This is dropping 32. Dropping 32, dropping 32. So I know right now that my slope is negative 32 over 1. I can tell by looking at it. But we're going to go through the steps that you're going to come and find a formula. First of all, what you do is you're going to write the formula for a line is y equals b plus mx. Unfortunately, they didn't tell us the original formula. So what I'm going to be doing is just going through here and making sure that I have all the points here. So I'm going to stack and rack. I don't know my initial value, so I've got 148 and 216. So the first thing you're going to do is find your slope. And I know it's negative 32 over 1, but let's show the work. So if I do the slope, I have 48 minus 16 over 2 minus 1. So that really comes out to be 32 over negative 1, or negative 32. So our slope is negative 32. So what we're going to do is actually put it in here and figure out what would be the formula would be without it. So I've got y equals negative 32. Oh, excuse me, the slope is negative 32. It's going to be b minus 32x, because I know the slope is negative 32. Okay? Now, to find the initial value, all you need to do is take one of the points. I don't care which one you pick. I'll pick the 216, but it doesn't really matter. And we're going to plug that in the xy spot. And when I do that, I can figure out what the formula is. So the x is 2 and the y is 16. So I got y equals 16 equals b minus 32 times 2. So I have 16 equals, what do we got here? 16 equals b minus 64. So if I add 64 to both sides to figure out what b is going to come out to be 80. So my formula is really y equals 80 minus 32x. But now we want to use the t's and the v's, and this is my x and this is my y. So in the y spot I'm going to put v equals 80 minus 32 times t. So there's my formula. And it has a negative slope, so if you'll notice this is going down. That's a good thing. That should be for the negative slope. Alright, let's look at another one here. Find the formula from this, and this is d and p. And if you remember, this is the distance and the percentage we talked about before. So let's talk about how we can find this formula. Again, I don't know the initial value, so I'm going to take any 2 points. They said it's linear, and we already looked before and found out it was linear by the carets. If you recall, this was going up 20 and this was going down 10. So let's do that. Y equals b plus mx. Stack and rack a couple points. I'm going to use 2090 and 4080. So I have y equals, and I don't know what the b is, but I think from here I can figure out my slope. So let's do the slope, delta y over delta x. And I'm going to do 90 minus 80 over 20 minus 40. So that's going to be 10 over negative 20, or negative 1/2. So now I can put that in my formula. I still don't know the initial value, so what I'm going to do now is plug in a point. So let's use the point 2090. Okay, so I'm going to use this 2090, and it doesn't matter. That's my xy. So I'm going to say 90 equals b minus 1/2 times 20. So 90 equals b minus 10. Add 10 to both sides, so b is going to equal 100. So my formula is y equals 100 minus 1/2 x. Now they told us to use d's and p's. This is x and y. So my formula really will be p, the percentage, is going to equal 100 minus 1/2 p. So there's my formula. Okay? Oh, excuse me, d. I put p there. It's half d. Sorry about that. Okay? Alright, let's look at the next part. We're going to find a formula from a graph now. So I put the table here, but all you got to do is pick a couple points and try to pick nice points. So I'm picking where they actually are crossing lines. So I got the point here, 0, 7. And I want to find another one where it crosses a line nice. So it looks like at 2, 4 it crosses the line nice too. Now on this one, the nice thing about this one is that I can actually find the equation of line a lot easier because I know it's y equals b plus mx. Well, I know the b because I know the y-intercept. It's 7. So this one you can actually just throw it in. Now I want to find the slope. Well, the slope I'm going to do separately, but I do know it's negative because the line is going in the negative direction. So let's stack and rack over here. So I have 0, 7. I have 2, 4. So let's do the slope. Is delta y over delta x. So the slope is going to be 7 minus 4 over 0 minus 2. So I have 3 over negative 2, or negative 3 halves. So my line is 7 minus 3 halves x. Okay? And you can always check this by graphing this yourself and looking at your table to see if those points are on there. You can always check by graphing. That's the beauty of doing this. You can do the algebra to show. Now the alternate forms of the equation of a line. The first one that we're doing this year is y equals b plus mx. It's very important. The second one we'll be using later this year is the point slope form, where you still have the slope in there, but now I have the point x0, y0 that I can throw in here. We'll be using this later. This is actually the most important one this year. I wanted to make sure you know how to use that one. And the standard form is ax plus by plus c equals 0. We will not be using that this year at all, but I just wanted you to have a slide where everything would be there. All right, we have one last problem, and we're going to talk about the owner of a greenhouse. And he incurs a cost of $5,000 per year to maintain the greenhouse facilities, and the cost of producing a tray of flowers is $2 per tray. So as soon as I see that per, I know that's my rate, and it's costing $2 per tray. So it says find a linear equation for this situation. Well, let's wait and let's answer these other questions. We'll go up there. What is the y-intercept? Well, the y-intercept, or the b, is the $5,000. That is the startup cost to get the greenhouse. And what is the slope? Well, the slope is going to be $2 for every one tray. Or that's the same as saying $2 per tray. So if I know that, I can go right ahead and do my formula, and we don't even have to use y. C is cost, R is producing the flowers, so I can say the cost of doing the flowers is my initial value of $5,000, plus it's going to cost me $2 per tray, and they want me to use an R. So there is my formula for that.